Good morning, everyone. In this presentation, we are going to see the basics in the electronics engineering studio, that is historical milestones in electronics. So, myself, Balamurli, AP2 from EC Department of Chemical Institutions. So, first developed electronic device is nothing but our vacuum tubes. So, let's see some introduction about the vacuum tubes. They are also called as electron tubes. Since the flow of electrons is happening in those tubes, they are called as electron tubes also. So by definition, we can say it is electronic device, so which can able to control the flow of electrons in a high vacuum environment. So here that vacuum is very important because the flow of electrons need to be controlled. If the flow is not controlled, so they will be scattered so that there is no proper electricity or the proper flow of electrons, so that we not able to get the proper current. So that is the reason why we need the vacuum environment for the flow of electrons. So if the vacuum is not there, so they will be easily oxidized, so they'll lose their energy very quickly. So that is the reason why we are keeping that flow in a vacuum environment. Then by application, they can be used, that is vacuum tube can be used to amplify, that is when weak signal is given, that can be getting amplified. That is a small portion of signal need to be amplified in the output. So in such cases, so that magnification is done by the amplification process. So it is one of the application of vacuum tubes. Then they can able to work as switches. So since uh, the progress like on and off can imitate the procedure of switching, so they can uh, used as switches, so that they can able to produce zeros and ones in digital devices, or in general they'll be on and off, or they can be used to modify an electrical signal. That is one form of signal can be converted into another form. Then regarding their history, it is invented in the early 20th century. So around 1904, it is invented by John Ambrose Fleming. So actually, even before him, many scientists have developed vacuum tubes, but very effective and efficient, and that is the vacuum tube which can be applied to some applications and fully functional is developed. That modern day development, the evolution of modern day. So that this evolution of electronics is done through that basic vacuum tube that is fully developed by John Ambrose Fleming. Then it is widely used till the invention of transistors. So it is a main one. The in the era of electronics, vacuum tubes are the basic. Then they have their own applications in all areas of electronic applications till the invention of transistors in the year of 1947. So from 1904 to 1947, the vacuum tubes have wide applications in electronics field. Then regarding their basic constructions, uh, they'll be consisting of multiple electrodes. Then those electrons are sealed inside a glass or vacuum envelope. Then so electrode means we are having uh, some some cathode or anode like devices. So one side will be used for emitting the electrons. Now other side will be used for accepting the electrons. For example, we are keeping cathode one side. So when it is heated, it will be emitting the electrons. Then the during after their flow, it will be get absorbed by the anodes. And then in the meanwhile, we'll be having some grids. So they'll be used for some purpose. Some grid will be used for controlling. So that alignment purpose, we are keeping some grids. So the grids which are having the magnetic field will be controlling that flow of electrons. They'll be making their flow steady. or uniform. They never allow them to be getting scattered. So some kind of things will be happening over there. Then the main thing is we are having the cathode that is emitting the electrons when it is heated. So that is called as a thermionic emission. So this emission of electrons due to the heat is called as a thermionic emission. Then regarding the mm, uh, working principle of vacuum tubes, first the electrons will be flowing from cathode to anode in a vacuum. So we have the vacuum environment. So over that environment, we have the electrons which are flowing from cathode to anode. Then, as I told you, if we want to keep many electrodes, we can keep on control grid. So that control grid can be used for controlling the flow of electrons. That is a current, controlling the current. So we are applying some voltage to the control grid. So based on the voltage, it will be controlling the flow of the electrons. Then regarding the types, so we based on number of electrodes used, so they are categorized into multiple things. So first one is called as a diode, the simple one, which has only two things. One is cathode, another one is anode. The next thing is triode. So along with the cathode and anode, when control grid is added for amplification, so it is called as a triode. So why we need a control grid for amplification means, so we can say mm, the prevention of signals from the loss also one kind of amplification. So the control grid will be used for making the flow in a uniform path. So it won't allow them to be getting scattered. So in such way it will be producing the amplification. So that is the entire signal will be getting collected at the anode. Then we have a tetrode and pentode. So when four electrodes are used, that is called as a tetrode. When five electrodes are used, that is called as a pentode. So this addition of electrodes will be giving some better performance to the application. Then also we have specialized tubes. So we have CRT tube, that is cathode ray tube. So it is used in old televisions, and it is used in computer monitors. And then we have the klystron. So when you operate with micro ranges for space application or any other applications, so we will be having the klystron. So that klystron tube will be having some cathode, then it will be having some that is bunching, absorbing walls, bunching, it will be having some bunching cavity. So through the electrons will be getting bunched. Then those electrons will be getting again absorbed by that walls of the cavity. So in such a way they will be working as klystrons. Then magnetrons. So they also used as used in magnetrons for producing very high heat. So even we are using the magnetron for home applications, or in industrial application when large amount of heat need to be produced. We are using them in industrial applications when less amount of heat need to be produced. For example, in our home we are using some that is microwave ovens. So in those ovens for heating the food, we are using the magnetrons. So there, the emission of electrons, then flow of electrons, that flow will be so will be making some required amount of heat. Such things will be happening. So those kind of the tubes are called as a magnetron tubes. So in some circularly field, the emitted electrons will be getting absorbed by the anodes. Then regarding their applications, as I told you, they have been used in early radios, televisions, and computers. So the olden day computer machines have used vacuum tubes. So the only drawback is because of their size. So the size of the computer machine is very large. Even the size of the radios as well as television devices are very large because of this vacuum tube. But even though even though it is big, it is a early form of development. So we have faced those difficulties in compactness of the device. Then they can be used in radars, microwave ovens. As I told you, magnetrons can be used in microwave ovens for making some application, that is heating applications or cooking food in a home. Then they can be used in oscilloscope. So in the laboratories, we are using for visualizing the flow of electrons, and to analyze any circuit, we are using the oscilloscopes. In such devices, we are using these vacuum tubes. So then they can be used as an audio amplifier. So we know that it's a main application of the that is vacuum tubes. So here the given sound will be getting amplified at the output. Then regarding their advantages, so they have a very high power handling capabilities. As I told you, they can be used in micro ranges. Those micro ranges can be used in large industries and space applications because of their high powers. Then they can be operated with high frequencies in even at the microwave region. As I told, the Castron magnetic tubes are working with microwave frequency regions, microwave range of or band of frequencies. So there we can use the vacuum tubes. The limitations, the main thing, the limitation is a large size and fragile. Since we are using number of vacuum tubes for based on the applications, their size could be very large. And then since the vacuum environment to be surrounded by this glass envelope, so they are very fragile. So that is one kind of a limitation. Then they have consumed very high power. So because of their physical property, that is one thing is it's needed for heating the cathode for to emit the electrons. In such cases, high power consumption has been happened. Then their lifetime is very shorter. Uh, because as we know that since the filament is to be heated often, so because of that their lifetime they have a reduced lifetime. Then if you want to uh, get with high lifetime or lifespan filament, they will be costlier. So these are the few limitations we are experiencing while use the vacuum tubes. Then their replacement. So as I told you, these systems, that is vacuum tubes, has been replaced with the transistors in early 1950s due to their smaller size, low power consumption, mm, and further applications. Then still used today in these applications. Some important applications still we are using the vacuum tubes. They are non-replaceable in such cases. In some RF transmitters and space and military applications, still we are using the amplifiers. So these are the basic things about a vacuum tube that is developed, or it's its era for electronics. It is a first machine, it is first device used in the electronics industry for its advancement. Okay, so thanks for the observation to the video today. Thank you.